I'm constantly hearing from people who dive into a new laser engraving or micro CNC project and end up with a table that looks perfect on the product page but turns out to be a wobbling nightmare when you try to line up the laser beam. You scroll through the specs, see a clean-looking aluminum frame, think this will finally give me that micron-level control, and then the first time you try to move the head you hear a clunk and the whole thing drifts. That frustration is why I wanted to break down the XY axis 2-axis manual motion stage from GGKLVWMA before anyone throws their hard-earned cash at something that might not fit their workflow. Link is in the description if you want to check the product details on Amazon. First off, let's talk about what this piece actually is. It's a 300mm by 220mm rectangular platform, about 90mm tall, equipped with linear motion guide actuators on both the X and Y axes. The guides are the kind you'd find in a small CNC router or a precision positioning bench, essentially hardened steel rails with recirculating ball bearings that let you slide the table with a smooth, predictable feel. The whole thing is meant to be operated manually, using two knurled knobs that give you fine adjustment without the need for any stepper motors or drivers. In practice, that means you're looking at a system where you set the position once, lock it in place, and then move it again only when you need a new reference point. Why does that matter? In the laser marking world, many hobbyists start with a cheap, off-the-shelf gantry that promises sub-millimeter accuracy but often falls short because the belts stretch, the frame flexes, or the firmware isn't tuned for the specific lens you're using. The manual stage sidesteps most of those variables because there are no belts, no motors, and no electronics to calibrate. The motion you feel is purely mechanical, which eliminates a whole class of error sources. If you've ever spent an evening trying to troubleshoot a jittery laser head and discovered the problem was a loose belt tensioner, you'll understand why a direct drive, manually adjusted platform can feel like a breath of fresh air. Now, the practical strengths. The first thing I noticed when I set it up on my bench was how compact the footprint is. At 300mm by 220mm it fits comfortably on a standard workbench without crowding other tools, yet it still offers enough travel for most small-scale engraving jobs. You can comfortably fit a 200mm square workpiece and still have room to maneuver the laser head. The linear guides feel solid. The knobs turn with just enough resistance to give you tactile feedback without being stiff, which makes those micro-adjustments feel intentional. Because it's all metal, the stage doesn't vibrate when you tap the table, so you can place a lightweight sensor or a small workpiece on it without worrying about resonance interfering with the laser's focus. Another point that often gets overlooked is mounting flexibility. The base comes with a set of M4 holes on all four corners, and the manufacturer includes a few optional mounting brackets that let you bolt the whole unit to an existing aluminum extrusion frame. In my own setup I attached it to a 2020 slot system, and the whole assembly stayed level even after a couple of hours of continuous laser runs. That kind of modularity is a big win for anyone who likes to reconfigure their workspace or experiment with different machine geometries. On the flip side, the very thing that makes it simple also caps its applicability. Because it's manually operated, you lose the repeatability that a motorized stage can provide. If you need to engrave hundreds of identical parts with the exact same alignment, you'll end up spending a lot of time reservoing the table by hand, and there's always a small chance of human error creeping in. The knobs don't have any built-in detents, so you have to rely on your own sense of distance when you turn them. There's no click stop that tells you you've moved exactly 0.5 millimeters. For most hobby projects that's fine, but in a production environment that uncertainty can become a bottleneck. Another practical weakness is the lack of integrated limit switches or safety stops. With motorized stages you often get electronic end stops that prevent the axis from crashing into the frame, but here you're entirely dependent on your own awareness. If you're moving the table quickly while trying to line up a laser spot, you could accidentally over-travel and knock the workpiece off the platform. The solution is simple, just be mindful of the travel limits and perhaps add a couple of external limit pins if you're worried about overshoot, but that does add a small extra step that some buyers might not anticipate. Who should really consider buying this stage? If you're a maker who runs a laser cutter or engraver a few times a week, need a reliable way to get the laser head into the sweet spot for fine detail work, and you don't want to deal with the extra wiring and firmware tuning that comes with a motorized system, this is a solid match.